Okay, so this is the introductory slide for the textbook that discusses the introduction to computing. And they're just trying to highlight how computing has become so ubiquitous and pervasive in nearly all aspects of our lives. There's so many areas that computers are being used, which you may or may not know about. But for example, in businesses, in business and finance, we use computer software quite a bit for like let's say accounting software or TurboTax. Uh, and businesses and finance also used computer algorithms, which we'll talk about briefly in a bit. They use them also for doing trading of stocks and whatnot. Industry uses it quite a bit, obviously. Government uses it in places, for example, like the FAA for scheduling flights. They have algorithms for scheduling the landing of planes and which order they should arrive in and when they should taxi off the runway, etc. In medicine, actually, that's used quite a bit for for storing electronic medical records. So every time you go to a hospital, they have, in most cases, they'll have an electronic medical record that stores your patient information, the doctor's notes, the drugs that you had to take, all sorts of billing codes and things like that. So in science, it uses it quite a bit, as you can imagine, for doing various sorts of things, from simulations of weather prediction models to for bioinformatics, just various different aspects. So, what is a computer? The book or the slide actually says a very general definition of how a computer is a general purpose data processing machine. So let's just sort of granularize that a little bit. What data processing is the transformation of raw data into information. So what is raw data? Raw data is just basically unorganized information that you have no context of. Think of like a text file that you opened up, and let's just say you have a text file on your computer. It has a bunch of numbers on it. You have no idea what that information is if you just have a random file you opened up. But once it's organized and it has some sort of labeling or structure to it, then that becomes information because it's something that you can use for meaning. So the transformation basically involves processing through a computer program. Okay, so what then is computer science? Uh, so one definition that the book uses is it's a study of algorithms, both their hardware and software realizations. Uh, Computer science has its roots in mathematics, and you could say that it really had its beginnings earlier on in about the 1940s or so. But some people say that maybe it started back in the late 1800s with Hollerith and his machines for processing census data. Computer science, really the core of it is the study of algorithms and how their algorithms are basically realized in the software that you program and also the hardware. And we're going to go more in depth in that in the course. I just wanted to throw that out there. So then what is an algorithm? It's basically a step-by-step method for accomplishing a particular task. Uh, and maybe more formally, it's basically, you can think of it as solving a mathematical problem in a finite number of steps. And so if you think about it, like, let's try to relate this to something that we all know. You can think of an algorithm as a recipe, right? So, a recipe has a set of instructions that once you give that to somebody, if they follow those instructions directly, I mean, exactly, they should hopefully have something produced a meal or baked bread similar to what you have done using the exact same instructions, right? So let's look at this a little bit in more detail. So the types of instructions that algorithms use are sequential instructions, selection instructions, and iteration or looping. And let's break that down a little bit. So sequential instructions are basically instructions that, as you may have guessed, you follow step by step. So the instructions have to make sense in the order that they're given. For example, let's see what the Saturday morning to-do list is. So the first thing it says is we're going to walk the dog. Obviously, that's not something you're probably going to want to do later in the afternoon, so that has to be the first step. And then you're going to want to rake the leaves, go to the grocery store, and then go to movie matinee, which it gives you the time earlier in the afternoon, right? So, very trivial example of sequential instructions. Selection instructions basically is like a conditional type of operation. So, for example, it says, if it doesn't rain today, then we're going to walk the dog and rake the leaves. Otherwise, we're going to go to the grocery store or go to the movie. So in computing, oftentimes we use selection type of operations or conditionals, as it shows here, to perform some sort of analysis. Like, for example, let's say if we're trying to compute someone's insurance premium, right? And let's say if they're under the age of 25, they're going to have probably a higher insurance premium, and if they're above the age of 25, they'll probably have less of a premium. So if you're programming this on a computer, you might have some statement like, if age is less than 25, then premium equals, I don't know, like $1,200 or something like that. Otherwise, it's equal to 800. I'm just pretty overly oversimplifying this, but just wanted to try to give you some sort of concrete example. And then looping is something that you're going to do over and over again until some condition is met, which causes you to stop doing the instructions in the loop. So here it says we're going to walk the dog, and while there are more leaves, so the walk the dog has nothing to do with really the loop step, but it's just something that happens before. And then they're saying, while there are more leaves in the leaf bag supply last, we're going to keep raking the leaves and stuff a bag. And once all that's done, then you're probably going to go to the store and potentially buy more leaf bags if you ran out. And then it says go to the movie matinee. Okay, so we talked about computers and algorithms, and I guess the whole point of this introductory slide was just to let you know that computers think a little differently, and the way you can program them and get them to do the type of stuff you want, to do the processing that you want, is to understand how algorithms work and the different types of control structures you can use for algorithms. And we talked about sequential instructions, which are basically instructions that have to be computed in exactly the order that you provided in. Otherwise, it wouldn't make sense if they were done out of order. Then there's conditional statements, which you perform one operation if the first condition's met. Otherwise, you perform the alternative operation. And then you have a looping type of structure where you perform some operation over and over again. And so the examples that were discussed here were basically real-world examples that you're probably familiar with, and trying to somehow relate that to an algorithm and its control structures. And this is something we're going to go through in more detail in the upcoming lectures and homework assignments. So just trying to get you warmed up with computer science and algorithms. All right, thanks.